Hello, our topic is utilizing fiber optic cables to channel sunlight into enclosed spaces by Nicole Harlambous.
And Harsita Thulasidas. In 2019, 3 million people in Africa and East Asia lack reliable access to lighting. Countries like in sub-Saharan Africa, for example, South Sudan, do not have access to a safe source of electricity. Currently, they use fossil fuels and kerosene lamps, which can cause air pollution. The pollution from the kerosene lamps can negatively affect the nervous system. Each year, 3.2 million people die from illnesses attributed to household air pollution. A solution to this is daylighting. Our research question is, what is the most efficient way to channel natural light sources into enclosed spaces? Some key terms to know are daylighting. Daylighting is the process of using materials to channel sunlight into enclosed spaces and buildings. Another key term is fiber optic cables, which are cables that transmit information in the form of light.
In these areas, kerosene lamps are used, but they provide a weak light source and can pollute and even cause respiratory problems for citizens living in those areas. Poor lighting can also make it difficult for children to study at night, which can negatively impact their education. And being in a dark room during the day is proven to reprimand mental health. With that, the absence of lighting can cause dark living spaces, which negatively affects visual health and can even cause mood disturbances, even running the risk of depression.
Daylighting is an innovative method that can be used to channel sunlight into buildings. This is a sustainable process. Daylighting enhances healthier outcomes and environmental conditions in sub-Saharan Africa. The technology utilized in daylighting systems is known for its capacity to reduce electricity costs while also being a heat-safe lighting source.
The purpose was to identify an energy efficient and environmentally friendly method for channeling light onto a small scale. A gap in this, however, is that the model daylighting system could not store the light to be later used, such as during the nighttime. The alternative hypothesis was that light harnessed from the fiber optic cables will have a greater brightness than a standard LED light bulb, whereas the null hypothesis is that there would be no difference in the amount of light harnessed from the fiber optic cables and the standard LED light bulb.
These are some key materials: the PVC tubes, the plano-convex lenses, and the light meters.
The PVC tubes, the fiber optic cables, and the plano-convex lenses were assembled together, forming a connector. This process was done 19 more consecutive times, and the connectors were glued into a larger PVC tube, which formed the daylighting system. The daylighting system was then elevated to an area of sunlight, which was a table against a window, and a hole was made in the cardboard box where the daylighting system was attached.
The model daylighting system design was then trialed in three types of weather conditions: sunny conditions, cloudy conditions, and rainy conditions. This was trialed 3 consecutive times.
A cardboard box represented the model room/building, and the model cardboard box had the daylighting system attached to it, and as light illuminated the model room, there was a light meter measuring the amount of lux being harnessed, and this can be seen by this video.
Data was collected and analyzed by using a light meter to find the amount of lux generated compared to the lux of an LED light bulb. To track this data, Google Sheets was utilized. The engineering goals were to build a device that harnessed direct sunlight, build a device that generates the same or greater amount of lux as an LED light bulb, and build a device that is safe indoors and environmentally conscious.
This data table shows the amount of lux in all different types of weather, and on the bottom are some key images of the daylighting system and the light meter.
The standard lux of an LED light bulb is approximately 100 lux in a general home. In the findings, during sunny conditions, the average lux harness was 194 lux. In addition, during cloudy conditions, the average lux harness was 109.1. So during sunny conditions, a daylighting system could be utilized in countries without proper lighting sources to harness sunlight, instead of using other methods such as burning fossil fuels and kerosene lamps. In addition, we could also use cloudy conditions as a way to channel sunlight, as it generates the same amount of a standard light bulb.
With this, a one-sample t-test was conducted for each type of weather condition to see if their lux values from the device was significantly different than that of 100 lux, which was from the light bulb. The alternative hypothesis was accepted during sunny conditions, and during sunny weather, the data was statistically significant. The null hypothesis was rejected, and the p-value was 0.001, and that is less than 0.05. and during cloudy weather, data was not statistically significant. The null hypothesis was accepted, and the p-value was 0.11, and although that is more than 0.05, it is important to note that it is still more than the 100 lux, which it is still about the 100 lux which is generated from the LED light bulb.
During rainy weather, data was not statistically significant. The null hypothesis was rejected and the alternative hypothesis was rejected. The p-value was 0.9, which is greater than 0.05. This is important as it is similar to a study done where researchers found out through their data that light illuminating a space less than 100 lux is not as efficient as greater than 100 lux. The cost of building this device was $130.65. Although this may not seem expensive, it is a one-time cost, and the device will continue to work as time progresses. An average 60-watt light bulb costs around $5, and the light bulb needs to be replaced infrequently requires electricity. The estimated annualized cost for electricity would be about 28 to 37 billion USDs in sub-Saharan Africa.
In conclusion, successfully built a daylighting system that harnessed over 100 lux in sunny conditions and about 100 lux in cloudy conditions. This is important as many countries without proper lighting are located in areas near the equator that have the sun for over half the year. So this type of daylighting system would be an appropriate alternative to traditional lighting systems, such as kerosene lamps, which are currently used and cause pollution. The device was tested during the late fall/early winter, where the angle of insolation is very low. If this device was tested later in the year when the angle of insolation is higher, or another altitude such as one closer to the equator that gets a higher angle of insolation all the time, it would produce more lux.
Some limitations were that using larger lenses could pose as a fire hazard since it was coming from direct sunlight, limited materials when building the model, and the device was tested during late fall/early winter when the angle of insolation was very low. Some future studies include a larger daylighting system, finding ways to preserve sunlight in other types of weather conditions, and analyzing lux in more different types of weather conditions. The significance and applications were that this could be used as an environmentally cautious and energy-efficient option in countries without proper lighting sources.
These are our references. Any questions? Thank you.